In this video, we're going to summarize some of the information that you should know for the velocity and acceleration problems. We're going to be doing two types of problems. All right, so first we'll talk about the vertical or free-falling motion problems. So here's the basic picture. In this case, we are assuming a ball is being thrown into the air, and in this picture, it's being thrown from a certain height, and it goes up, and then it reaches a certain height, and then it comes back down again because gravity is acting on the ball. So the distance of the ball from the ground, which is represented by this function, here's s of t. Okay, so s of t is this distance in feet. Is given by a function of this form, where t is seconds. Okay, so the units are seconds and feet. And it always starts, if we're talking about an object that is being thrown up and down, and gravity is acting on the object in order for it to fall down, so gravity is going to play a role in this function. So that's why this function always has a certain form. It always starts with minus 16t squared plus, and then we have the initial velocity, that is velocity at time 0 times t, some constant over there, plus the initial position, that is the position from the ground, or the distance from the ground at time t equals 0. So this S0 is actually going to be this, in this picture, S0 is the height of this box, and v0, the velocity, depends on how hard the ball is thrown when it's thrown up in the air. Okay. So the picture that I represented is the case where the ball is thrown from a certain height, but it is possible that the ball is thrown up from the ground, pushed up from the ground at a certain, or shot up from the ground, up and down, and it is possible that the ball is just simply being dropped from a height. So those are the different possible situations. All right, the other type of problem that we'll be looking at is called a horizontal motion problem, and here the distance function, or the position, here we call s of t usually a position function. The position function can be anything at all. S of t represents the position of a particle on the x-axis. So here the particle is starting at 2, so initially s of t is going to be equal to 2 in this picture. And then it just, moves. In this picture it's moving to the right, and then it's moving to the left. And at any particular time, s of t is going to give you the position of the particle on the x-axis. Now, as far as the units go, we're assuming that we're just going to say that s of t is equal to units, unit distance, and t is equal to unit time. We're not going to assign any particular units. Okay, so let's look at what these functions look like again. Let me just once again reiterate that s of t, in the case of vertical motion, is the height of a ball from the ground. Or in the case of horizontal motion, s of t is the position of the particle at time t on the x-axis. Okay. Now, the velocity. Well, velocity really represents change in distance, how quickly distance is changing. And in class we discussed that the derivative tells us how quickly a function is changing at any particular t value or x value, depending on what our variable is. So the derivative tells us how quickly a function is changing. Remember, derivative is the slope of a tangent line. So if you have a function that's increasing quickly, like in this picture, see over here it's increasing quickly, the tangent line is going to be pretty steep, and the slope of this tangent line tells us the function's increasing quickly at this point. Or here it's kind of increasing slower. this function is leveling off a little bit, and the slope of this tangent line tells us, so here the slope of the tangent line is smaller, and that reflects the fact that the function's increasing more slowly at this point. Okay, again, so the derivative represents how quickly the function is changing. All right, so how quickly distance is changing. That would be represented by the derivative of the distance function, and that would be called the velocity function. How quickly distance is changing is velocity. Now, velocity sometimes changes. Let's suppose you're driving a car and you speed up, then you're changing your velocity. And what is it calling? What is it called when you speed up? That's called accelerating. So how quickly velocity is changing is your acceleration function. So the acceleration function is given by the derivative of the velocity. Derivative of velocity tells us how quickly velocity is changing. So it makes sense that that would be acceleration. Okay, again, velocity is derivative of distance. Acceleration is derivative of velocity. And then we have a concept of average velocity. The average velocity is given by the distance function or the position function, depending if we're talking about vertical or horizontal. Okay, so the average velocity is given by the s function, the distance function, and it's actually a slope. So it's not a derivative, it's close to a derivative, it's just a slope. The average velocity between two times a and b, t equal a, t equal b, is given by this slope. Now here are some typical questions that we could be asked about velocity and acceleration problems. Okay, the first is, what is the initial position? Initial means when t equals 0. So if we're talking about position, position is the s function. Initial position would be s of 0. Similarly, the initial velocity would be the velocity function with 0 substituted in. Okay, and remember, how do we get the velocity function? Well, velocity we get by taking the derivative of the distance or position function. We're always given s, and then we figure out v. We figure out v by taking derivative. Initial acceleration, well, that's just the acceleration function with 0 plugged in. And how do we get acceleration? Well, okay, we're assuming first we got velocity by taking derivative of distance, and acceleration we get by taking derivative of velocity. Okay, when does the ball hit the ground? That is, when is s equal to 0? Now remember, when it says when, that means we want to get a t value. So when does the ball hit the ground? We are solving s of t equal to 0 and just solve for t. And in the case of horizontal motion, when does the particle reach 0? Exactly the same. S of t equals 0 again. So these two are the same, these first two. What is the velocity when it hits the ground? Well, let's say we solve for t over here, and let's say we end up with t equal t1. So that's when the ball hits the ground. What's the velocity? We'll just take this t1 value and you substitute it into velocity. Or that's the same for horizontal motion. The question would say, what is the velocity when the particle reaches 0? Again, just take that solution to this, assuming it's t1, and again, just substitute in. When it hits 0, substitute into the velocity function. Okay. What is the acceleration when the particle reaches 0? And so this problem is being stated for the horizontal motion, and the acceleration when the particle reaches 0. Again, take that same t1 value, that's the time when the particle reaches 0, and just substitute it in. Okay, here, when does the ball reach maximum height? Maximum height? Okay, so if we go back to that picture that we had, okay, here we are. All right, so the ball is going to go up and then down again. When the ball travels up, the velocity is positive, and when the ball travels down, the velocity is negative. So positive, negative, in between it must be zero. So the maximum height occurs when the velocity is zero. So we solve basically v of t equals zero to get the time when the ball reaches the maximum height. So again, when does the ball reach maximum height? Do v of t equals zero and solve for t. Similarly, when does the moving particle change direction? Okay, let's look at the picture again. Okay, when the particle is going to the right, the velocity is positive. When the particle is going to the left, the velocity is negative. So in between, it's zero. So here is where, when it changes direction, it's going to change direction when the velocity is zero. So same, the same type of situation as before. In the vertical motion, maximum height is when the ball changes direction, goes from up to down. So here we ask, when does the ball reach maximum height? And here the same question, or the analogous question in horizontal motion is, when does the particle change direction? And again, v of t equals zero is how we get that. Okay, when does the moving particle change direction? Solve v of t equals zero. Now, a related question, we have what is the maximum height? So again, let's say we solve v of t equals zero, and let's say our solution is a particular value, t1. Then the maximum height is given by s with t1 substituted in. Or similarly, what is the position of the particle when it changes direction? This is for horizontal motion. Just take that t1 value that tells us when the particle changes direction and substitute it in to the position function. And finally, the last type of question is, what is the average velocity? Usually you'll ask for the average velocity between t equal a and t equal b. And in both cases, it'll be given by a slope, s of b minus s of a over b minus a. So you have the distance traveled on top divided by the time. Basically, it's distance traveled over time. All right, you have the starting distance minus the ending distance. The end distance subtracts starting distance. End time subtract start time. So that's basically a distance over time. Distance divided by time. And that'll give us the average velocity. Just one more word about the vertical motion problems, all right, or in particular about the distance function itself. Remember, it's always in this format. So the velocity, if we take the derivative of this, in this particular example, take the derivative and we get minus 32. It always starts with minus 32t. Minus 32t plus, in this case, 32. And if we substitute in 0 over here, we get 32, which, remember, that's the initial velocity right there. Okay, let's look at the acceleration function. That's really what I was getting at. Take the derivative of the velocity for the acceleration and we get minus 32. So that's gravity. So the acceleration isn't very interesting. That's the force of gravity, minus 32 feet per second per second. Per second per second, we write per second squared. So the acceleration function isn't very interesting. It's just a constant function. All right, because gravity is the only thing acting on the ball that's being thrown up and falling down again. So the acceleration is really determined by gravity. So it's not a very interesting function. So usually we're not asked questions about the acceleration function in the vertical free-falling object problems. Usually it's in the horizontal motion problems that we might be asked a question about acceleration.